This video introduces the idea of collinearity. So we know if we've got two parallel lines, we call them L1 and L2. The gradients of each of these lines, let's call the gradient of L1 M1 and the gradient of line L2 M2. We know the gradients are going to be equal because they're parallel. It works the other way. If we know the gradients are equal, then the lines must be parallel. In some cases we're not actually given the gradient, we have to work it out for ourselves. So if it's in a different form to y equals mx plus c, we'll have to do some rearranging. If we have two lines which are parallel but also have a common point, then we say any points on these lines must be collinear. If, for example, you use the points A and B and C, we have to state that the gradients are equal. Therefore, MAB is equal to MBC. Therefore, AB is parallel to BC. That's what those two lines are for. Now you can see that B is a common point. B is common to AB and BC. So then A, B and C are collinear. It's the points that are collinear, not the lines. Now we'll go through an example here. We've got 3 points E, F and G. Now, let's work out the gradient of EF. So M of EF. Now we're working out loads of gradients here, so we're going to have to subscript it with EF. So we know that the gradient is for this line between E and F. So gradient of EF is going to be, let's say it's 5 minus 8 over 5 minus 3. That's going to be minus 3 over 2. Let's have a look at the gradient of FG. So the gradient of FG, MFG, is going to be minus 1 minus 5 over 9 minus 5. So that's minus 6 over 4. That simplifies down to minus 3 over 2 as well. Now, just going to run to the next slide because this is the important bit. We can see that the gradient of EF is the gradient of FG, so the gradients are equal. What we'll now say is the gradients are equal, therefore EF is parallel to FG, as AF is a common point, E and F and G are collinear. So we've got our working up here. We know that MEF, we've already worked it out, is minus 3 over 2. We know that the gradient of FG, we've worked that out, is minus 3 over 2. So we can see that this is true. And if the gradients are the same, then we must have two parallel lines. F is common to both. We have to state that, and then we say the 3 points we're looking at, E and F and G, are collinear. That needs to be said, that needs to be a stated proof for any of these questions. So, that's it for collinearity. Have a go at the questions I've put down at the bottom of this slide.